Jai Hind, everyone, I am from Computer AI of India. Today's we are discuss about C++ programming language. Ever wondered how the C++ programming language came into existence? Well, sit back and let's delve into the fascinating story of its birth. C++, pronounced C++, is a high-level general-purpose programming language that has become a cornerstone in the world of computer science. It was created by Danish computer scientist Bjarne Stroustrup. In the late 70s, Stroustrup began work on an ambitious project initially dubbed C with classes. This project was the precursor to what we now know as C++. The inception of C++ was driven by Stroustrup's desire for a more efficient and flexible language. He wanted a language that was not only fast and portable like C, but one that also provided high-level features for program organization. He found inspiration in the Simula language, which had features that were very helpful for large software development. However, Simula was too slow for practical use. On the other hand, BCPL was fast but too low-level to be suitable for large software development. So, Stroustrup set out on a mission to enhance the C language with Simula-like features. His vision was to create a language that was general-purpose, fast, and widely used, but also boasted high-level features for program organization. In the early stages, Stroustrup's C with Classes project added features to the C compiler, including classes, derived classes, strong typing, inlining, and default arguments. Over time, this project expanded and evolved, ultimately leading to the birth of C++ in 1985. C++ was designed with systems programming in mind. It was intended for use in embedded, resource-constrained software and large systems. Performance, efficiency, and flexibility of use were its design highlights. Since its inception, C++ has found use in many other contexts, proving its worth in software infrastructure and resource-constrained applications, including desktop applications, video games, servers, and performance-critical applications. So that's how C++ was born, out of a desire for a more efficient and flexible language. And the rest, as they say, is history. Stay tuned as we dive deeper into the evolution and development of this influential language in the next segment. From its inception, C++ has undergone significant changes. Let's delve into its evolution. The development of C++ was marked by the addition of several key features that set it apart from its predecessor, the C language. One of the most notable of these is the concept of classes. These are fundamental to the object-oriented nature of C++, allowing programmers to bundle data and methods together into a single entity or object. Derived classes further extended this concept, introducing a hierarchy of classes where a child class could inherit properties from a parent class. This allowed for more efficient and organized code, as common properties could be defined once in a parent class and then used by any number of child classes. In order to ensure that data was used correctly, C++ implemented strong typing. This meant that each piece of data had a specific type, and the compiler would enforce rules about how these types could interact. This helped to catch many errors at compile time, rather than at runtime. Another key feature was inlining, a technique that allows the compiler to replace a function call with the function's code, potentially improving performance. Additionally, C++ introduced default arguments, which allowed programmers to specify default values for function parameters. But C++ didn't evolve in a vacuum. It was influenced by a number of other languages, each contributing a piece to the puzzle. Algol 68, for instance, influenced the syntax and data structures of C++. Ada contributed to the strong typing and modular programming. CLU brought along the concept of iterators, and ML influenced exception handling and type inference. As we can see, C++ has been influenced by a number of other languages and has continually evolved to add new features. This constant evolution, driven by the needs of its users and the influence of other languages, has made C++ the versatile and powerful language that it is today. Did you know that C++ is standardized by the International Organization for Standardization, or ISO? This process began back in 1998 with the first standard version, known as ISO IEC 14882-1998. This version set the groundwork for what C++ is today, but it was just the beginning. As technology evolved, so did C++. The language was amended several times over the years to keep up with the rapid pace of change in the world of programming. These amendments, known as C++03, C++11, C++14, and C++17, each brought new features and improvements to the language, enhancing its capabilities and making it more versatile. C++03, for instance, brought minor corrections, clarifications, and new library features to the table. C++11, on the other hand, was a major update that introduced several new language features, new libraries, and performance improvements. C++14 and C++17 continued on this path, each bringing their own set of new features and improvements to the language. But the journey of C++ doesn't end there. The latest standard version, ratified and published by ISO in December 2020, is known as C++20. This version supersedes all previous versions and includes new features, as well as an expanded standard library. It represents the current state of C++, reflecting the most up-to-date practices and features of the language. The standardization of C++ is a testament to its importance and relevance in the world of programming. It ensures that no matter where you are in the world, if you're working with C++, you're working with the same language. This consistency is vital in a field where collaboration and understanding are key. The standardization process also underscores the adaptability of C++. With each new standard, the language evolves and adapts to meet the needs of programmers, reflecting the changing landscape of technology. This makes C++ a dynamic, versatile language that can be used for a wide range of applications, from developing complex system software to creating engaging video games. Standardization has allowed C++ to become a widely adopted and universally understood language. It's a language that continues to grow and evolve, meeting the ever-changing demands of the programming world. So, where do we see C++ in action today? In the world of system programming, C++ is a key player. It was designed with system programming in mind, and its features reflect that. It allows for low-level memory manipulation, which is essential for operating systems and microcomputers. This makes C++ a go-to language for creating intricate software that interacts directly with the hardware of a computer. Moving beyond system programming, C++ also thrives in the realm of embedded software. It's a language that's efficient and flexible, making it ideal for software that has to run on resource-constrained systems. This could include anything from a smartwatch to a microwave oven. Its efficiency and flexibility allow software developers to get the most out of limited resources. Now, when we talk about large systems, C++ shines again. Its design enables it to handle the complexity and scale of these systems. It's the language behind many large-scale applications, such as databases and e-commerce servers, providing the backbone for many services we use daily. C++ also finds its place on our desktops. Many desktop applications are written in C++, given its ability to deliver high performance. It's the muscle behind many graphics-intensive applications, like photo editors and 3D modeling software. In the gaming world, C++, again, is a dominant force. It's the language of choice for many high-end video games, providing the power and speed necessary for smooth gameplay. It's used in game engines, graphics rendering, and real-time simulations. Moreover, C++ is also used in performance-critical applications, such as telephone switches or space probes. These applications require a language that is efficient, reliable, and fast. C++ fits the bill perfectly. Its features allow developers to optimize their code to the point where every microsecond counts. C++ has found its place in a wide range of applications, making it a versatile and valuable language to learn. Let's recap what we've learned about C++. We started our journey with the birth of C++, a brainchild of Bjarne Stroustrup. It was conceived in 1985 as an extension of the C programming language, aiming to deliver an efficient and flexible language that also provided high-level features for program organization. Stroustrup's experiences with Simula's helpfulness for large software development and BCPL's speed, though lacking in high-level concepts, fueled the creation of this new language. Next, we delved into the evolution of C++, which has grown significantly since its inception. Its growth has been driven by actual problems, with every feature designed to be immediately useful in real-world programs. C++ now boasts object-oriented, generic, and functional features, along with facilities for low-level memory manipulation. Its design highlights remain performance, efficiency, and flexibility of use. We then explored the standardization of C++, which is overseen by the International Organization for Standardization. The C++ programming language was initially standardized in 1998 and has undergone several amendments since, with C++ 20 being the latest version. This process ensures that C++ continues to evolve in a structured manner, with new features and an enlarged standard library. Finally, we looked at the practical applications of C++. It was designed with systems programming, embedded, resource-constrained software, and large systems in mind. However, its utility has been recognized in various other contexts. Today, C++ is employed in software infrastructure, resource-constrained applications, desktop applications, video games, servers, and performance-critical applications. It is a testament to its adaptability and robustness. Thank you for watching this video. Please share this video. In conclusion, C++ is more than just a programming language. It's a testament to the power of thoughtful, problem-driven design and the relentless pursuit of efficiency and flexibility. It has shaped the programming landscape and continues to do so, demonstrating its relevance and resilience in a rapidly evolving digital world. C++, though born out of necessity, has evolved into a powerful tool that continues to shape the landscape of programming,